Since aerobic digestion utilizes microorganisms to degrade organics, it is very important to understand these biological processes and their associated chemical reactions. If the chemical reactions are not fully understood, issues such as odors, alkalinity depletion, ammonia accumulation, high pH, low pH, and excessive total nitrogen going back to the head of the plant can occur. The first biological process in an aerobic digestion system is the biomass destruction. In biomass destruction, food supply is depleted, so microorganisms consume their own protoplasm to obtain energy for cell maintenance reactions. This reaction is described in the following chemical equation. The biomass requires 5 moles of oxygen in order to oxidize its own protoplasm. When the protoplasm is oxidized, it is reduced to carbon dioxide, water, and ammonium bicarbonate. This reaction describes how volatile solids reduction occurs in an aerobic digestion system. Essentially, under these conditions, the bugs will eat themselves, which means you need to haul less of them off. As shown in the biomass destruction reaction, ammonia is produced in the system. It is not only critical for ammonia to be reduced because it is very toxic to microorganisms, but it is also the cause of pungent odors. In order for ammonia to be reduced, nitrification, which is the second biological process, must occur. Nitrification is accomplished through nitrifying bacteria. In this step, nitrifying bacteria oxidizes ammonia with 2 additional moles of oxygen, reducing it to water, 2 moles of acidity represented by the hydrogen atom, and nitrates. Combining the biomass destruction with nitrification reaction, the biomass requires a total of 7 moles of oxygen for both processes to occur. The byproducts of the combined reactions are 5 moles of carbon dioxide, 3 moles of water, and 1 mole of nitric acid. Consequently, nitric acid is a very strong acid and can kill the biomass because microorganisms are very sensitive to pH conditions. In order to reduce nitric acid in the process, the denitrification process must occur. Denitrification is the final biological process in a controlled aerobic digestion process. Denitrification is accomplished in the absence of oxygen. This forces the biomass to oxidize 4 moles of nitrates, which is reduced to ammonia bicarbonate, which is a form of alkalinity, and 2 moles of nitrogen gas. Combining the biomass destruction and nitrification with the denitrification step results in the biomass oxidizing only 5.75 moles of oxygen and reducing it to 5 moles of carbon dioxide, 3 moles of water, and half a mole of nitrogen gas. It is very critical in the denitrification process to create an environment without oxygen, because microorganisms will prefer to oxidize oxygen instead of nitrates. Without this step, nitric acid will continue to accumulate and consequently deplete the alkalinity, making the environment inhospitable for the biomass. Alkalinity recovery due to the denitrification step is important because it can neutralize the nitric acid created in the nitrification process. Aerobic digestion is a critical piece of many treatment plant solids handling solutions.